Introduction to exponential functions. We're going to compare some functions. Here's a linear function, the linear parent function. Here's the quadratic parent function. And finally, here's an exponential function. We see this one starting low to the left and going up exponentially as it goes to the right. And we go to our function editor and put in the linear parent function y equals x, and this is what it looks like as we change the parameters and make, in this case, y equals 2x minus 3. This is what it looks like. If we put in the function y equals negative 4, we have a horizontal line at y equals negative 4. And here's our quadratic parent function, y equals x squared. And if we change the parameters, we make it 2x squared minus 6. We make the parabola narrower and translate it down 6 units. Now for this function, y equals negative 0.5x squared plus 3x plus 5, with the negative sign in front of the quadratic term, we turn it upside down, and so that's what this one looks like. And now we have x to the power of 2, which is the quadratic parent function, but put in there differently. Instead of with x with the little 2 above to the right, what if we change places and swap and make it instead 2 to the power of x? Well, this is what it looks like. It's an exponential function and not a quadratic function. And if we superimpose over the quadratic parent function, and now we zoom in on it, and we can see the different appearance, and that's just by swapping the x and the 2. Now, there are two types of exponential functions. There's a growth function, and this is what it looks like, starting small to the left and going up to the right. And there's a decay or decline function. It starts high to the left and goes down, crossing the y-axis to approach 0 eventually on the right. In one case, we have the function y equals 2 to the power of x, and in the decay function, we have y equals 0.5 to the power of x. And these two functions happen to be mirror images of one another. Now for some examples of exponential growth, and they are found in nature. Growth by cell division, population growth, growth of money through compounding. We have a construction of the musical scale. An exponential decay. We have radioactive decay. Half-life is usually the phrase used with that. Population decline, production decline in the oil and gas industry, depreciation, usually used for cars and equipment. Now a linear function has the same rate of change throughout the domain of the function. For example, in the function y equals 2x minus 3 for an input of 0, output is negative 3. For an input of 1, it's negative 1. The output increases by 2 for every unit input increase. The slope or rate of change is 2. And here we see it in the table form, numeric representation, and we see that we have, with each input value going up by 1, each output value goes up by 2. So that's what we call a constant rate of change. Now for a quadratic function, it has a rate of change that increases by the same amount for every unit change. And for example, in the quadratic parent function y equals x squared, an input of 0 gives an output of 0, an input of 1 is 1, an input of 2 is 4. For every input increase of 1, the output value difference increases by 2 every time. And here we have it on the right. We have that 1, 3, 5, 7. And that increase or second difference increases by 2 with every unit change. Now an exponential function, it has a rate of change that increases or decreases by the same multiple or percentage for every unit change. And here we have the function y equals 2 to the power of x. And we see on the right side, it goes up from 1 to 2 by multiplying 1 times 2, 2 to 4 by multiplying 2 times 2, and 4 to 8 by multiplying 4 times 2. So that's a factor of 2 with every unit increase. Each new output is found by multiplying the prior output by a factor. Sometimes it's given in percentage. And here we have the function y equals 1000 times 1.045 to the power of x. And when the factor is greater than 1, there is growth. And over a short enough span, like in this function we see here, an exponential function can appear to be linear. This particular function is compounding $1,000 annually at an interest rate of 4.5%. This graph covers 10 years. And with time, we see the value of the investment goes up, hence it's a growth function. Now another function, y equals 100 times 0.9998, etc. to the power of x. Here we have a situation where the factor is less than 1, and so there is decline or decay. This function is of the decline of carbon-14 due to radioactive decay. The graph spans 40,000 years. And over time, the amount of carbon-14 remaining goes down. As it decays, it changes back into nitrogen, and so that's very useful. Now we have another function, y equals 220 times 1.059, etc. to the power of x, and that's notes follow that exponential relationship. A below middle C is defined as 220 hertz or cycles per second. Every half step up the chromatic scale is a percentage increase of 5.94631 over the previous tone. So middle C, being 3 half steps up, has a frequency of about 261.63 hertz or cycles per second. And here we see that graphed. This is a brief introduction to the concept of exponential functions by comparison to linear and quadratic functions. Also, we showed examples of growth and decay. Hope this lesson has been enjoyable and instructive.